Hi Level 3s and welcome back to 3.6 Lesson 2. This is Part B of aqueous chemistry and we're talking about concentration changes and Le Chatelier's principle. So we'd just spoken about previously in the last video about how we can use a side reaction of a complex ion to decrease the concentration of a species in equilibrium. The hard part here is you do actually need to be familiar with these complex ions. So the complex ions I've put in bold are the ones that you need to know. You can actually derive the equations if you know the complex ion off by heart. So if you know that this is the complex ion, then you know you need 4 ammonias and 1 copper ion. So I recommend just learning the complex ions. There are some helpful hints because in the question it'll say add excess of either NaOH or KOH, and if they add excess of NaOH or KOH then it's going to be one of these complexes with the OH minus in brackets, and if they say add excess NH3 then it's going to be one of these complexes with NH3. Now there's a little tidbit that you can use to kind of help you out in these situations, and that's the fact that most of these complex ions have 4 behind the bracket, and so for instance this one's got 4, this one's got 4, this one's got 4, this one's got 4, and this one's got 4, so it's actually easier to kind of remember the thiocyanate doesn't and the silver doesn't, and that makes things a little bit easier for you. So you do need to learn these, then you can just work out the equation once you've got the ions memorized. So NH3 with 4 means 4 NH3 and 1 zinc ion, 4 hydroxides, 4 OH minus, 1 zinc ion. You can actually work out the charge of your complex ion, because if the zinc is zinc 2 plus and you've got 4 OH minuses, that leaves a total charge of 2 minus. Okay, zinc is 2 plus, ammonia has no charge, so therefore the charge is 2 plus. Iron is 3 plus, SCN 1 minus, that gives a 2 plus. So I hope that makes sense. Okay, the third way that we can remove a species from an equilibrium is the addition of an acid or base. This will only work on equilibrium systems where there are acid-base particles actually present, and so the example that I'm talking about here is calcium hydroxide today. So if we've got calcium hydroxide dissolving in a beaker of water, you're going to see me talking about dissolving solids a lot because that's what this whole topic is, so that's why I'm using these examples. So we've got calcium hydroxide dissolving into calcium ions and hydroxide ions. This is an equilibrium reaction. And so when we see solid calcium hydroxide in the bottom of a beaker, we know that this equilibrium's been established and the forwards and reverse reactions are happening at the same time. So what could we do to change the concentration here of hydroxide ions? So if we wanted to decrease the concentration of hydroxide ions, what we would actually do is add an acid. And so if we add H3O plus particles, this side reaction happens where H3O plus and OH minus join together to form water, and this is neutralization, and this is a one-way reaction. So that's actually going to remove our hydroxide ions from the equilibrium. And we know the equilibrium will shift to do the direct opposite. So it's going to shift to increase the concentration of hydroxide ions. And if it's shifting to increase the concentration of the hydroxide ions, it has to shift to the right to make more. So the equilibrium will shift to the right. Okay, and this, if it shifts to the right, you're going to get more of the solid dissolving. So therefore more calcium hydroxide dissolves. And so that's all that happens. So if you have an equilibrium with an acid or basic particle, like this one's got basic particles, we can add an acid. This side reaction happens, and you would be expected to produce this equation. This side reaction happens, and that means that the concentration of our hydroxide ions in our equilibrium has been decreased. The equilibrium will shift to increase the concentration of the hydroxide ions, and therefore it'll shift to the right, and therefore more of the calcium hydroxide dissolves, which is pretty cool. So I hope that makes sense. So by the way, you should know this table of ions and what these are called off by heart. So this is the ammonium ion. Don't get confused. Ammonia is NH3. Okay, these are all the same as the elements. So sodium ion, potassium ion, silver ion, hydrogen ion, lithium ion. I'm not going to go through all of them. Okay, and remember that these ones have an "ide" at the end. So this is oxide, sulfide. This one's carbonate. Okay, sulfate. Now you should know this. This isn't a biggie. This is hydrogen carbonate. Okay, and nitrate, hydroxide, and chloride. So you should know that, but I just thought I'd say them to you just in case. Okay, So here's a task to see if we've actually understood what we've been going over. So we've got this equilibrium up here, okay, and straight away you can see that it contains basic particles. Okay, and it says what would happen if the pH of the solution was dropped. So when they say pH of the solution was dropped, they're meaning that an acid has been added, because acids have a low pH between 1 and 6.9, okay, and bases have a high pH from 7.1 to 14 at room temperature. And so that's what they're meaning. So they're adding an acid. So if we add an acid to this reaction, what's going to happen is the H3O plus particles that we add are going to react with OH minus to produce two waters. Now, if that happens, the concentration of our OH minus ions in our equilibrium is going to decrease. This means that our equilibrium is going to shift to increase the concentration of hydroxide ions, and it'll do that by shifting to the right. And so if the equilibrium shifts to the right, we're going to get more of the FeOH3 solid dissolving. Okay, I hope that makes sense. So it says here, discuss how the solubility of silver chromate, solubility just means how much dissolves, would change if it was placed in a solution of NH3 instead of water. So instead of dissolving this, they should have aqueous, apologies for that. So instead of dissolving this just in water, we put it into NH3. Now, as soon as you see NH3, alarm bell should go that we're talking about a complex ion. Okay, now because you've learnt the complex ions, this becomes a bit easier. But if this was to happen, your silver ions actually react with 2 NH3, so this is one of the ones that's not 4, and it forms this AgNH3 2 complex ion. Okay, now if that happens, then the concentration of our Ag plus ions in our equilibrium have been decreased because the side reaction of the complex ion has happened. So our equilibrium is going to shift to increase the concentration of Ag plus, and if the concentration of Ag plus is being increased, or to increase it, it has to shift to the right. So the equilibrium is going to shift to the right, and that means that you're going to get more of the Ag2CrO4 solid dissolving, which if there's more dissolving, then solubility has gone up. Okay, I hope that makes sense. So here's some more examples. Okay, so what if acid is added to the following reaction? This one's a little bit harder because carbonate ones are just a bit trickier. So if you add acid, carbonate ions are basic. So if we add carbonate ions to H3O plus, then you're going to end up producing CO2 and H2O. Okay, now we have to do, well, that's just it really. So that's our equation there. So now what we're going to do is balance it, because you'll see that we don't have a balanced equation here. You've got 3 hydrogen ions on one side and 2 on the other. So if we times this by 2 and this by 3, you've got 6 on each side, and so now we're going to check our oxygens and check they work. You've got 3 oxygens from the carbonate plus 2 from the H3O plus, that gives 5. You've got 2 plus 3, that gives 5, so we're fine. So that's how you balance that equation. This one's the hardest one, and they love asking this one, so make sure you can do this equation. So if we add acid to this, this means that the concentration of CO3 2 minus will be decreased because these ions are being removed from our equilibrium. So the equilibrium will shift to increase the concentration of the carbonate ions. So if the concentration of carbonate ions are to increase, the equilibrium must shift to the right to replace them, and therefore more of the CaCO3 will dissolve. So hopefully you're getting into the picture, into the fact that when we decrease the concentration, the solubility of things goes up, because that's the natural change. So if we add NH3 to this reaction here, it's going to be a side reaction, and it's going to form a complex ion. When you see NH3, you just know it's a complex ion, so you have to have learnt them. So there are 4 NH3s for the copper one, NH3, and it'll have a 2 plus charge. So if we form this complex ion, that means that the concentration of Cu2 plus in our equilibrium has gone down. The equilibrium will shift to increase the concentration of Cu2 plus. It'll do this by shifting to the right, and therefore you're going to have more of the CuSO4 solid dissolving. I hope that makes sense. This one here says if the pH of the solution is increased. Now, an increase in pH means an increase in hydroxide ions. Interesting. So if they're increasing the hydroxide ions and we've got hydroxide ions, that's a hint that this question is about a complex ion. And so actually the complex ion is the lead complex ion, where it's lead plus 4OH minus goes to Pb, OH4, and then that's going to be 2 minus. So this is actually a complex ion one where they've told you that you're adding more hydroxide to something that has hydroxide to form the complex. So if this happens, that's going to remove our Pb2 plus from equilibrium, so the concentration of Pb2 plus will decrease. So the equilibrium will shift to increase the concentration of Pb2 plus. The equilibrium will do this by shifting to the right, and therefore more of the solid PbOH2 will dissolve. Sorry, I ran out of room there, but more will dissolve. And I've written all of these out for you so you can go through and at your own time and have a look at them. So if you've got any questions, you can let me know. And now as a class, we're going to do some workbook pages and the answers will be on your OneNote. Okay team, I'll see you shortly for lesson 3. Thank you.